Alright, so here we have the actual probability questions. I didn't do too many of these just because I'd already done so much of your homework. If you got more questions, you just ask me in the morning or afternoon whenever you see me. Part 1 of this one, this talks about your end of course test. It says it's way harder than expected, so you just guess between A, B, C, and D on all of it. Not even talking about the chances of getting multiple select right, which are lower than you think. Is this a binomial experiment? Yes, comma. You are either right or wrong. Plain and simple. You're either right or you're wrong. The probability of success is going to be 25%, which is 0.25. It's 4 choices, A, B, C, or D. The cutoff to be a level 3 is to score at least 60%. What was my chance of being a level 3? So I don't know what kind of notes you're going to take, but you need to be writing down some stuff here. This would be equal to 1 minus the probability of at least 60%. I need to figure out that. At least 60%. I do 0.6 times 40, which means I get 24 or more questions right. That means I can get 24 right, or I can get 25 right, or I can get 26 right, or I can get 27 right, dot, dot, dot. All those ors means what I'm doing is I'm finding the probability of 24 plus the probability of 25 plus the probability of 26 plus the probability of 27, dot, 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 all the way to the probability of 40. That's going to take a minute. I don't have that kind of time. I really don't. So what I'm trying to talk about here is this would be the complement. It's equal to, we're going to use the complement of at most 13, or the complement of 13 or less. We're going to do the probability of 24 or more is going to be 1 for 100% minus the probability of 23 or less. Now the probability of 23 or less is pretty simple. We're going to use that binomial CDF function. And we've got 40 trials. The probability of success is 0.25. And we're going to do 23. Now the C stands for cumulative. All right? So binomial CDF, it finds the probability of 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 and so forth. Does it all for you. So I can use that one. So let's fire up the TI-84. We've got second VAR's binomial CDF. Cumulative density function is choice B. There's 40 trials. We have a 25% chance of success. That's my p-value. And the x value here is 23. That's going to find the cumulative density of 0 through 23 and add it all together for me. And it's tiny. It's 0.9999714. 1 minus that thing. We got scientific notation here. 5 zeros followed by 2826. So, moral of the story is guessing will not get you level 3. Let me say this, blind guessing. Paying attention to that, blind guessing ain't going to do it. That's your chance of success. It ain't going to happen. Alright, next off we have level 2. Now, there's actually more than 40 questions here. I just chose 40 to make the numbers easier to use. But 35% of 40, 0.35 times 40, should be 14 or more right. So 14 or more right is the complement of 13 or less. Keep that in mind. It's the complement of 13 or less. So to find this one, we're going to do kind of the same thing. We're going to do 1 minus So it's going to be 1 minus binom CDF. 40 trials, probability of success 0.25, 13 right. Man, I got brain drain today. I'm going to highlight the old function I did, and I'm just going to overtype. Need a 13 in there. 1 minus that. This isn't too bad. 0.1032. So what this is saying is you have roughly a 10% chance of testing level 2 by blindly guessing. That's actually not too bad at all. It's really not. Who would have thought? So there's hope for some of y'all yet. Now, this is blind guessing. Just imagine if you knew some stuff, right? The state thinks I'll test level 1. What was my chance of success? So it's kind of what we did here. Notice we use the complement. This is the complement of not testing level 2. Everything beneath. So it's just this piece right here. You had to get 14 questions right. So we're going to type that in. I think I've already got the answer. It's 0.8968 according to my calculator. There you go. So what you just learned here is blind guessing means roughly an 89% chance of testing level 1. Now, there's a lot of kids. That includes the probability of getting nothing right, 1 right, 2 right, 3 right, 4 right, 4 right. There are a lot of kids where high level 1 is growth. There is. I don't want you testing level 1, but for a couple of y'all, a high level 1 is growth. How many distinct ways can the letters of Alabama be rearranged? I kind of wish I had some more time to explain why these work the way they do work, but it's pretty simple. We're just going to count the number of letters here. Alabama has what? Boy, I'm tired. 7 letters? Alright. That's if we think about non-distinct. 7 non-distinct, non-different. 7 non-distinct letters. Now, I'm going to count some letters. The letter A happens 4 times. It's because of the repetition of that letter. It doesn't matter which A you pick. You still get the same word to some degree. So you still get the same arrangement. An A is an A. It doesn't matter if it was the first one, second one, or third one. I don't think anything else in the word Alabama repeats. So this one's pretty simple. It's 7 factorial divided by 4 factorial. Now, if you think about how this works, you'd have 7 times 6 times 5, and then you get the 4s. I don't need a calculator for this. It's 7 times 6 times 5, and then the 4s cancel top and bottom. So 7 times 6 is 42, times 5 again is going to be 210 ways. 210 ways to rearrange the lettering of Alabama. Last one I'm going to do. An unbiased coin is tossed 10 times. Find the probability that there are fewer than 3 heads tossed. So this would be the probability of no head, plus the probability of 1 head, plus the probability of 2 heads. Fewer than 3, right? So I could just not use the CDF function. I could do binom, and I'm going to do this because I have time and I want to show it. 10 trials, it's unbiased coins, heads, tails, probability of success is 0.5, 0, plus binom, and this needs to be a PDF, not a C. 10.5, 1, plus binom, PDF, 10.5, 2. That won't take me too long to type in. Let's see what this gives me. Second, VARS, binomial probability distribution formula. 10 trials, probability of getting head is 50%. First off, we're going to start with a 0. Now, if you flip a coin 10 times, this should be really, really small. Yeah, it is. It's tiny. Plus, the same thing, but this time, probability of getting heads is 1. Alright. And the third time, the probability of getting heads, I'll change that 0 into a 2. And I put them all together. I get 0.0547. Now, I could do that. Or, and hear me out, I could use the cumulative density function. Binom CDF. And this time it'd be 10.5. And I would just put a 2 in there. I should get the same thing. If my brain's working right, I should get the same thing. If it's not, Milbrath needs to delete everything I've just recorded. And I'm having one of those days. So 10.5, 2. Good. Same thing. 0.0547. And this is one of those questions you can ask, like, does this make sense? It kind of does. Everybody in this room has flipped a coin. So it makes sense. The odds of you getting 2 or less is really, really small. It's 5%. And that, I believe, boys and girls, is all I've done on your homework. So I've done 2, 3, 4, 5, 6, 7, 8, 9, 10 of your homework problems. I think there's only like 17. So there you go. I did most of it. Any other questions? Ask them.